In this demo, we are going to build an amortization schedule, looking at different interest rates and calculating some mortgage payments. So this is a pretty typical kind of project you might undertake in Excel, but we're going to look at some new ways of doing some of these things. One of the first things we're going to look at is renaming cells. So up until now, we've really just referred to cells as their coordinates. So for example, this one right here, the monthly payment is F6. But we can also give that cell a name. So here we called it monthly payment. And now you can refer to that term, or refer to that cell just by using that term, monthly payment. Also total interest, total cost, and things like that. So for example, over here, rather than just referencing cell D8, we're just referencing loan amount because we've renamed that cell. Another thing we're going to look at is the PMT function. So PMT takes a few different arguments, the rate, the number of payments, the length of the term, and gives you the monthly payment. So in this case, we're looking at a mortgage with a loan amount of $344,000, a 15-year term, and an annual rate of 4.125%. So we can figure out the monthly payment by using this PMT formula, and we'll look at how to build that formula in a little bit. We'll also look at protecting cells and protecting sheets. So if you're going to share a project like this with somebody else, you might want to protect the sheet and not allow anybody else to make any modifications to it. So we'll look at ways of kind of locking the sheet down. We're going to look at different ways of doing these borders. So we have different borders in this case here, and different thicknesses and different types of borders. And we are also going to look at setting up some ways of printing the sheet and making sure that the whole sheet is going to print. We're also going to hide and unhide worksheets, so you can have multiple sheets that aren't displayed. Sometimes it's for checking things, or sometimes it's for some additional information, but you can hide and unhide sheets. So this is what it's going to look like when we're all done, and in the next step I'll get started in actually building this out. So this is our starting point for the sheet. We have our mortgage payment calculator details right here. We have a table that we're going to build out based on the different interest rates. Then we have an amortization schedule, which is going to show the balance and the interest paid of the loan over the 15-year term. So to start off, the first thing that we're going to do is rename these cells. So rather than just referring to things as D4 in this case, or F6 in this case, we can give these an actual term that makes sense. So to do that, we're going to highlight the left and the right column. So what I want to get to is naming this one date, this one item, this one price, this one down payment, this one loan amount. So the cells on this side should be named the exact same thing as what's describing them. So the title, I guess you could say, is on the left hand side, and we want to give these cells those names. So if you highlight both columns, then go up to where is it now? I just lost it. Formulas. And we're going to click on create from selection and define names. So that's under formulas with both columns selected. So if you click create from selection, it gives you a new dialog box and asks you a little question here. It is the left column that we want to take the names from. So create names from values in the left column, which makes sense. This cell will become date, this cell will become item, and so on. So if we click OK, now it doesn't look like anything happened until we click on the cell. So if I click on D8, it doesn't say D8 up here anymore, it says loan amount, which is what's written here. Down payment, price, item, and date. If I click on another kind of random cell over here, it gives me Q15 up in the corner because that's what we haven't renamed it yet. So I'm going to do the same thing for this column here, formulas, and then under define names, create from selection, left column, and now we have the cells named. Just to make this a little bit easier to see, I'm going to zoom in a little bit. There we go. Now we can see things a little bit better. So to continue to work through this mortgage payment calculator, it might be worth just taking a quick detour to kind of go through the details of the mortgage in this case. So the purchase price of the house is $429,000. The down payment is $85,000. So that means this person is buying a house that's valued at $429,000, but they have $85,000 cash on hand. So they need to get a loan to make up the difference. And the way this loan is structured is it's going to take them 15 years to repay that loan at an annual interest rate of 4.125%. So that means that every year they're going to have to pay 4.125% of whatever value is left on the loan back to the lender. So it's going to cost them some money to make this loan. The monthly payment is going to be how much money they're paying, and that includes both the principal, so how much they're paying down against the loan, but also that amount of interest, or the penalty in some way of taking out that loan. So the monthly payment is the principal and the interest. Total interest is going to be the total amount that the loan costs, so the total amount that gets paid in interest, and then the total cost is the amount of the loan plus the interest. So let's add a simple one first. So date, we're just going to put today's date, and we're going to use the today function for that. And then the loan amount is just the price minus the down payment. So the cost of the house is $429,000, and they have $85,000 cash on hand, so they're going to need to take out a loan for that difference. So we can either just refer to the cells, this cell minus this cell, or now because we have named these cells, as I start to type down, you can see down payment is an option. If I click on that, it's the same as typing in D7, but a little bit easier to read. So then I'm going to say down payment minus, or sorry, not down payment, that should be price. Should be price minus down payment, and then I press enter. So they have to take out a loan for $344,000 in order to purchase this house. Next, we'll work through the monthly payment, total interest, and total cost. So monthly payment, here we're going to use a formula called PMT. So if I take equals PMT, the little hint here calculates the payment for a loan based on constant payments and a constant interest rate. So that's how you pay down a mortgage. The amount of money you pay each month is typically constant. The mortgage rate is constant, and you have a certain period that you're going to pay this down. So in this case, it's a monthly payment. This term is 15, so that's 15 years. So we have to do a little bit of math to figure out the exact length of time, because this one is asking for months, and this one is giving it to us in years. So we'll use PMT. So I'll double click that. And in the hint here, it says the rate, NPER, which is the number of periods. So the amount of payments that you're going to make over the course of this term. PV is present value. Future value and type, we don't need to worry about those. We're only going to use the first three arguments here. So the rate is pretty simple. It's just this rate, but it's not just that rate. So it's not 4.125% every month. It's 4.125% annually. So we're going to take that rate and divide it by 12. So the annual rate divided by 12 months. Then the number of periods is the number of payments that you're going to make over the course of this mortgage. So we have the term, 15 years, but it's not annual payments. We're making these payments monthly. So we're going to do term times 12. So 15 years times 12 months, that's the number of payments that are being made over the course of this loan. And then the present value is just the value of the loan. It's not the value of the house or the purchase price of the house, it's how much was borrowed for this loan. So we can click on that and then close the bracket and press enter, and this should give us the monthly payment. So in this case it gives us a negative $2,566, which is technically correct because a loan is a negative value, but to change this to a positive value, we're going to put a negative sign in front of this, so negative PMT, and then if we press enter, now it gives us a positive value. Next, we're going to calculate the total interest and the total cost of this loan. So total interest is really just the amount of money that this person paid over the course of the term of the loan, and the difference between that and the actual amount of money they borrowed. So just like any loan, you have to pay back more than you borrowed. Otherwise, nobody would lend out that money. There has to be some kind of a benefit from the person lending out that money, or from the institution lending out that money. So to figure that out, the total interest is just the amount of money that was paid over the course of the loan, and the difference between that and the actual loan amount. So here we're going to say that the total interest is the term, so 15 years, and we this term, or this mortgage, is being paid monthly, so 15 years times 12 months times the amount paid each month. So $2,566.13 is paid each month. So that times 12 is how much is paid in each year, and that times the length, so term, 15 years, is the amount of money that gets paid to pay down this loan. So that's the total amount of money paid. And we're going to subtract the loan amount from that. So if we look at this again, because this is multiplication, this will calculate first, and then we're going to subtract the loan amount from that. So again, we have the term, 15 years, times 12, because this is monthly, so that's the number of payments, times the amount of that monthly payment, minus the original value of the loan. So if I press enter here, that means on a loan of $344,000 over 15 years at 4.125 annual rate, the cost of that loan, or the total interest of that loan, is $117,903. Seems like a lot of money, especially when we look at the rate thinking it's only 4% and change. It's actually quite a high percentage of the original loan amount, because it's spread out over so long. So the total cost is just the total interest plus the loan amount. So over that 15-year period, this person is paying $461,903 to borrow $344,000. So now we have the mortgage payment calculator all complete, and next we're going to move to looking at some different rates. So we're going to build a table here looking at, okay, right now the rate is 4.125%. What if it was 3%, 3.125%? And we're going to build out a whole bunch of different possible scenarios to see what the differences will be when it comes to the overall cost of interest. So because this is such an expensive proposition here, it's worthwhile to build out some other scenarios. So we're going to look at what if the annual interest rate was a lower amount, or just a different amount in general. So I'm going to show you the finished one, and if we look at this one here, so in this table we're just trying to create a table that shows interest rates at 3%, 3.125, 3.25, and so on, all the way up to 4.25%. Then we can see what the monthly payment might be, the total amount of interest paid, and the total cost over that 15-year term. So we don't actually have to calculate each one over and over and over. We can use a data table to figure that out. So to do that, the first thing that I'm going to do is just look at these different rates. So let's change these into percentages. So 3.125, and rather than typing everything out, I'm just going to click and drag to get up to 4.25%. Then in this table here, notice I have a gap on row 11. In the way we set up this data table is we have the monthly payment, total interest, total cost across the top without the rate in the first row, and then we're going to refer back to this rate up here later on. So the first step is to add the monthly payment in here in the original term. So monthly payment is just this one here. Total interest is this one here, and total cost is this one here. So now we have, and I'm going to change these to accounting just so we can see the dollars there. So we have the monthly payment, total interest, and total cost in this scenario up here that we calculated earlier. And you can probably hear my dog snoring in the background now. But next we're going to, rather than calculating this over and over and over again for all of these different rates, like we would have to do up here, we can build this data table to do that for us. So I'm just going to click and drag to highlight C11 to F22, and then going up to data, what if analysis, and then data table. And in the column input cell, we're going to refer to this rate here. So the rate is 4.125%. So notice it's a locked cell, or the absolute value of the cell. There's a dollar sign in front of the F and in front of the 4. And then now when I click OK, in that one little click, it's going to calculate everything for me. So now you can see that as the rate goes higher, the monthly payments increase, the amount of interest also goes up, and then the total cost of that loan increases as well. To make it a little bit easier to read, I'm going to change the format of that. So you can see that the difference between a 3% loan, $427,000 for the total cost, and a 4.25% loan, only a difference of 1.25%, but it's almost $40,000 difference. So these tables are nice when you're trying to compare a few different scenarios, in this case comparing a bunch of different mortgage rates. So the next thing we're going to do is build this amortization schedule, which is just showing in each year what the beginning balance, the ending balance, the amount paid to principal, and the amount paid in interest. So because we have 15 years in the term, so the length of the loan is 15 years long, we're going to create a row for each one of the 15 years. So each one of these rows will represent 1 year. Beginning balance is pretty easy. In year one, the beginning balance is just the amount of money that was borrowed. But in each following year, that will change because the amount of money that's owing will change. It'll go down as this person pays down that loan. The ending balance, this gets a little bit tricky here. So the ending balance is at the end of year one, we've paid $2,566.13. We've paid that 12 times, but it's not just a simple calculation of that times 12 subtracted from the loan amount. Some of that $2,566 goes to interest, so it goes to pay down that rate, and some of it goes down to pay down the loan amount. So you can think of it as the stuff that's going to pay down the loan amount that reduces the amount borrowed. The other stuff, the interest, that goes to the bank or to the lender as their cut for lending you this money. So the ending balance in this case is, we're going to start with PV and PV is present value of the loan. The first thing it asks us for is the rate, and we're going to say the rate is F4. Oops. F4, and we're gonna use an absolute reference there, because as we copy this formula down, we want to make sure that we're always referring to that same rate. But it's not just that, it's that rate divided by 12. Remember that this is our annual rate, so this gets calculated annually, but this mortgage is being paid monthly. So we have to divide that by 12 because there's 12 months in a year. The next thing it asks us is the number of payments. So here we're saying 12 times, we're going to do a little bit of math in here. So 12 times the term length, so F5, and again we're going to put an absolute reference there. But because this changes every year, we're going to say the term is F5 minus H5. So at the end of this year, so our ending balance is the value of the loan after 1 year. As we kind of copy this formula all the way down, this one will be the end of the loan after 9 years, end of the loan after 13 years, end of the loan after 15 years, and so on. So we have the number of payments left is that that value there. Oops. After number of payments, the next thing that it's going to ask us is the payment, which is going to stay consistent. The monthly payment is always $2,566.13. So I'm going to use an absolute reference there to F6. And that gives us our, oops, found a typo. And that looks good to me. So 12 times, I forgot to add the multiplication between 12 and that cell reference. So that looks good to me. The ending balance is, we still owe $327,078.92. We are going to make this a little bit better. This isn't perfect just yet. You'll notice that there is a, this is showing us a negative number, but we want that to be a positive number. And there is one little issue here. For example, if I copied this all the way down, after the loan is done, it's giving me some weird stuff here. So I'm going to delete all of this, and well, I'll leave that for now. The first thing we have to change is we're going to put a negative sign in front of the cell reference there, because it's actually a payment we're making, which is a negative value. So adding a negative in front of F6. Now the ending balance, we want to see that as a positive number, and that's $327,078.92. So this loan in year one, day one, started at $344,000, and by the end of the first year went down to $327,078.92. That's how much is left on that loan in the first year. But we're going to wrap an if statement around this as well. And the reason we're going to do that is we only want to calculate this if the loan is still happening, right? We don't really care about year 16, 17, 18, 19 because the loan is done. So one way to do that is we're going to put an if statement saying if H5 is less than or equal to F5, then give me the present value of the loan. If not, put a 0. So here all we're saying is if the year number is less than or equal to the term, then do this calculation. If not, just add a 0, and you'll see what this means in a second. So that looks good. If I drag this all the way down, that works perfectly. So in year 16, that really doesn't make any sense because the term of the loan is only 15 years long. So here it's saying if H20 is less than or equal to the term, which it's not, it's greater than the term. So because that's false, we're putting a 0 in this case. But we don't need year 16, so I'm going to delete that, and then we'll move this back up here. So up next is the amount that's paid on the principal, and that just means the amount of money that goes to paying that loan down. So that is just the difference between this amount and this amount. Pretty simple calculation. This minus this. So $16,921.08. So paying $2,566.13 per month for 12 months only pays down the principal by less than $17,000. Where does the rest of that money go? The rest of that money goes to interest. So it goes to the lender, and that's their share of offering you that loan. So the interest, we can calculate that just by saying the term here. So we'll start this. So let's say equals 12 months times F6. So 12 months times the monthly payment. And we have that calculation there. So if we just take a look at what that equals, so the total amount, this isn't the interest paid yet, but the total amount of money that was paid to the loan in that year was $30,793.54. That's just this monthly payment times 12. $16,921 of that went to pay down the loan, and the remainder goes to interest. So here we're going to say is that minus the amount paid on principal, or paid to principal. So $13,872.46 went to interest. $16,921 went to pay down the value of that loan. But this one isn't quite perfect yet. We're going to wrap an if statement around this as well. So if I5 is greater than 0, then do this calculation. If not, we'll add a 0. And all we're saying here is if the loan still exists, then there's interest being paid. If not, put a 0 there instead. So we have a little bit more work to do. We figured out this first year. We figured out the ending balance of the other years. Now we just need to figure out the beginning balance and these other values as we go down here. So the beginning balance in year 2 is just the ending balance in year 1. So the last day of year 1 and the first day of year 2, it's the exact same thing. The principal, this calculation, we're just copying that all the way down, and same with these others. So here we can just grab both of these, drag those all the way down, and because we haven't done all of this yet, there we go. So the beginning balance in year 1, $344,000. The ending balance in year 1 was $327,078.92. $16,000 went down to paying that balance down. $13,872.46 went to paying the lender. And you can see that the value going to the lender drops every year, and the amount that pays down the loan goes up every year. And that's just the way that interest is calculated on a loan. So in this first year, and the monthly payment always stays the same. In this first year, in year number 1, you're paying 4.125% of $344,000, which is this amount here. In year 2, you're paying 4.125% of this amount, which is this amount, and so on as you go down. So as the amount of the loan gets smaller, the total amount of interest gets smaller as well, because the rate is consistent and the monthly payment is consistent. So we can finish this off by looking at the subtotals, down payment, and total cost. So the subtotal of the of all of these put together should equal the amount of the loan, because this is the amount paid to principal, and that gives us exactly $344,000, which is what we saw was the borrowing amount here. And then the subtotal of interest paid, this should give us the same value over here, 117,903.13. So that's the total amount that went to interest. So that was the cost of borrowing that money. This is how much was borrowed, and this is how much extra we had to pay, or this person had to pay, for borrowing that amount. So the down payment in this case is just this number here. The total cost of the loan is the subtotal of the amount paid on principal plus the amount paid in interest. And if you want to get the total cost, including the original down payment, then we can just add the down payment. So to buy this $429,000 house with $85,000 down at 4.125 over 15 years, the total cost was $546,903.13. So we have all of the values looking pretty good. Everything's accurate. Next, we're going to change the formatting a little bit. So we'll just do some pretty common stuff here. I'm going to add a title for each of the titles, and then we're going to add some borders. So the way we can add borders in Excel, there's a few different ways to do it. This way is a little bit finicky, a little bit tricky, but we'll look at one way of doing it here. So if I wanted to add some borders around this part, let's say, I can highlight everything, right click, and then format cells, and I can click on the border tab here, and it gives me a few kind of different options here. I have no borders, outline, which just goes around the edge, or inside, which also will do these individual kind of lines as well. It's a little bit kind of unusual, so play around with it and make a few mistakes, then go back and kind of resolve things. But the goal that I'm trying to do in this case is put a thick blue border around this part, and then a lighter blue border in the vertical lines. So to do that, I'm going to click on the line style here, just a regular line. The color, I'm going to click this blue here, and I'm going to add an outline. Actually, you know what? I'm going to make it a little bit thicker. So I'll click that thick border, and then I'll click outline, and you can see that I have a thick border all the way around here. Next, I want the same blue, and I only want vertical lines here, but I want it thinner. So I've clicked this thinner line, and now I'm going to click this to add vertical lines through here. And now if I click OK, you can see I have a thick blue border and then light blue borders in between there. Next, I'm going to add a border around the interest rate. So this data table here, right click, format cells. I'm going to make it that blue color again. I'll put a thick border around the outside, and then I'll make a thinner border around this part here, and then I can click OK. Across the top here, I'm going to right click again and format cells, and across the bottom. So because I've only selected part of this now, I just want to put a lighter border around the bottom edge here, but I want to keep the thicker border on the left, the top, and the right, and I want to keep that thin border between everything here. So that's what it's showing right now. It doesn't show a border across the bottom, so this looks good. What I want to do is make sure that I have the lighter, kind of thinner style, and then the color is accurate, and I want to add this line across the bottom. And now I have that bottom line. And I'll do something similar for this one as well. Highlight everything, format cells, change the color. The outside border is going to be the thicker border. The inside vertical is what I want there. Then through here, I want to put a line, a thin line, right through there. So I can right click, put a thin line through the top there. I want to keep that thick border around the bottom and the thin border through the vertical. So I have that one, and then I just want to add one line across the bottom there, thin line across the bottom, and that looks good. I'm going to make that a little bit smaller, a little bit too big there, and the formatting looks pretty good. The only thing that I want to do next is use some conditional formatting to highlight this actual term that we're looking at here. So we've created this rate table to show the different possible rates, but this mortgage payment calculator and this amortization schedule is using this rate right here. So it would be nice to quickly highlight what rate we're using in this table. So to do that, I'm just going to click conditional formatting, highlight cells that are equal to. So I want to highlight cells that are equal to the value of this cell, and I'll make it green. So here we're just looking at this is the rate that matches up here. So you can see the total cost, 461,903, matches there. Other than that, I think we can add a little bit of, maybe we'll do an outside border around everything here. So we're going to do an outside border like this. Outside around everything, thicker border, and we'll do this one green. And we'll fill the background with a white color. Now you can see I have a white background there, and then maybe I'm just going to kind of change the size. Oops. Make that a little bit smaller, not bigger. This is really just visual more than anything. And now we have kind of a nice little setup showing us our payment calculator, rate schedule, and amortization schedule. If we were going to go print this right now, it would be cut off a little bit. So we can go to page layout, and actually maybe first we'll go to the view, page layout, and here you can see that this is how things would be printed if we were just to print it right now. So looking at the page layout view, it's going to show us what it would look like if it was to be printed. If we go to the orientation, I'll change that to landscape, and still we have a little bit cut off. So if I change the width to 1 page, and in this case I don't have to change the height to 1 page, but I will just to make sure, just in case something got added later on. So now we have everything on 1 page. Let me go back to just a regular view. So normal view, now that we have everything kind of in the proper print area. So the final thing we're going to look at is locking this sheet so that if you sent this to somebody else, they would be able to change the rate and the term, but they wouldn't be able to change anything else. And this is very, very common. If you sent this to somebody and they tried to make a change over here, or accidentally deleted a formula or changed a reference, it would be really, really difficult to kind of troubleshoot and figure out what's happening. If you did want to give them some flexibility to change the rate or the term of the loan, let's say, that makes sense. That would be pretty common. But you want to be able to do that with only allowing them to change little bits at a time. So the first thing that we're going to do, we're going to decide which cells we want them to be able to change, and that's the rate and the term in this case. And we'll right click, go to Format Cells, and then under Protection, you're going to unclick Locked, which might sound a little bit counterintuitive at first, but it'll make sense in a second here. So those 2 cells are the only ones that are not locked. Click OK. Still, everything is the exact same. But the next thing we're going to do is click Protect Sheet, and then make sure that Select Locked Cells is unclicked. So you're only going to protect the unlocked cells here. You can also add a password to unprotect it. And sometimes that is good practice as well, but keep in mind, if you forget that password, then you're kind of out of luck. So we'll click OK here, and now you'll notice that if I click anywhere, can't do anything. Click and drag, can't do anything. I can only click on these 2 cells. So I could change this to 20 years, and that recalculates everything for me. I could change this to 2.5%, and it'll recalculate everything for me as well, but nothing else. It won't let me change anything else. It won't let me modify the formulas. It won't let me delete anything. It won't let me make any edits until I click Unprotect Sheet. And if I had a password on it, then I would have to put in that password before I was able to unprotect the sheet. So this is the end of the file, and we've gone through quite a bit of information. We built out a mortgage payment calculator using the PMT function. We renamed cells, we've built a data table, and we've added some different borders and formatting options as well.